This video will be some sample problems from section 3.2. I'll begin with problem number 6. It says, for the following exercises, rewrite the quadratic function in standard form and give the vertex. First, I want to note that our book uses standard form, and the video both use the word standard form for what we have typically in algebra called vertex form. So I'm going to refer to instead of standard form, vertex form. It's the form of the equation y equals a open parentheses x minus h quantity squared plus k, where this h and k is the vertex. Our book calls general form ax squared plus bx plus c is equal to y, or sometimes you'll see 0, whatever the case may be. Most books will call this either general or standard. And so if you hear me say general or standard, I mean the ax squared plus bx plus c. Vertex form will have the vertex in it. So I'm going to do problem number 6. 6 says we have f of x is equal to x squared minus 12x plus 32. In order to get from general or standard form into vertex form, we will complete the square. The first step is we're going to group our variables inside of parentheses and put the constants outside. So in this case, x squared minus 12x inside of parentheses and our constant outside. If we have a coefficient, if a here is other than 1, we need to factor out that number. In this case, it's 1, so we don't need to jack with that. Next step is we're going to add in some box number in order to complete the square. You may remember this from algebra 2. So x squared minus 12x plus some number. I'm just going to call it a box. And outside, we will subtract the box. Typically, we think of whatever we do to one side of the equation, we do the other. Here, we're doing it strictly to the right side, so we add it inside and subtract it outside. Well, what is the box number? It is 1/2 of b squared, where b is the coefficient of our x term, in our case minus 12. So we're going to take half of minus 12, and that'll be minus 6, and we will square minus 6, that will be 36. That number will go in the box. So f of x is equal to x squared minus 12x plus 36, and then 32 minus 36 outside. All right, now we are going to write this trinomial as one binomial squared. The special thing about the box number is it made this a perfect square trinomial. So we can rewrite this as x, simply the square root of the first one goes first, and then half of this b number. Minus 12, we can write this as minus 6, quantity squared. If I bothered to square this to distribute, you would see that it would be equal to this. Outside, we have 32 minus 6. That's going to be a minus 4. Now we can identify the parameters a, h, and k. A is our coefficient here, in this case 1. And h and k, that's the vertex. It's the opposite of this. This is minus 6, so h will be positive 6. Think inside inverse. And it's exactly this out here, minus 4. Note in our vertex form, it's minus h. So you need to think the opposite of this. So a gives us the direction of opening. If it's positive, it opens up. Negative, it opens down. And h and k tell you where the vertex are. So on number 6, we have written it in what they call in standard form. We're going to call vertex form, and we've given the vertex. So this is the form we're looking for. and our vertex is 6, -4. It's number 6. All right, next, number 18. For the following exercises, determine whether there is a maximum or minimum value. Find the value of the axis of symmetry. So number 18, we have h of t is equal to -4t squared plus 6t minus 1. All right, we could do the same process that we did a second ago to find the vertex, but I want to show a slightly different and probably easier method. We can locate the axis of symmetry. First, let's back up. We want to know if it's going to be a maximum or minimum. That's determined by here in this case, a is a -4. So when we graph this parabola, it's going to be opening downward. Thus, our vertex would be a max, a top value. It's a max in this case. All right, to find the axis of symmetry, super easy. Axis of symmetry will be given to us by the equation x equal, because if it's opening upward or downward, the axis of symmetry would be a vertical line, -b divided by 2a. In our particular case, b is the coefficient of our linear term. It's 6, so -6. 2 times a is the coefficient of our quadratic term. 2 times -4. So that is -6 over -8, and that reduces to 3/4. All right, if we wanted to find the vertex from here, well, the vertex, the axis of symmetry goes through the vertex. So the vertex will be whatever this amount is, comma, whatever the y pairs with. So the vertex is going to be this same value. It's going to be 3/4, comma, whatever 3/4 pairs with. I could write it as a question mark, or I could think it's f of 3/4, or h of 3/4 in this case. It's 3/4 is my input value, in this case t, and whatever it pairs with, I could call it h of 3/4. So let me substitute 3/4 in for t. So h of t is -4t squared plus 6t minus 1. I'm going to substitute in a 3/4. To square a fraction, you square the top and the bottom, so this becomes -4 times 9/16. Multiplying a whole number by a fraction, we can simply multiply by the top, or we can do some reducing. Between 6 and 4, 2 goes into both of them. That would make this a 3. 3 times 3 is 9/2. Multiplying -4 times 9 would be a -36, or again, 4 goes into 4 once, 4 into 16, 4, so this becomes -9/4 plus 9/2 minus 1. If I wanted to add these fractions, I need a common denominator. It would be 4, so that would double both of these, would leave 18/4. -9/4 and 18/4 would be a positive 9/4. Subtract 1. 9/4 would be $2.25, minus 1 would be 1.25. So our vertex would be 3/4 and 1.25. 3/4, 1.25 is 5/4, 5/4. And as we said, that vertex is going to be a max because the parabola is opening down. number 24, for the following exercises, determine the domain and the range. Well, for our quadratic functions, domain is going to be very easy. It's going to be all real numbers. And if you think about the way the domain is x, input. When you think about it, the way a parabola that opens upward or downward, it eventually is going to capture all x values. Okay. The range, pretty easy. It's all about the vertex. All right. Range, find that vertex. Once you find the vertex, it's just going to be, that's going to be the minimum or maximum value, and the rest of the y's will be above or below that. So in this particular example, number 24, two x squared minus 4x plus 2. 2x squared minus 4x plus 2. Why is that? All right, f of x or y. I could do it in either of the ways I showed the previous one. I'm going to repeat the completing the square method because we have a different a here. I think it'll be useful for you. So I will begin by grouping my variables inside the parentheses and the constant outside. All right, notice I factored out a 2. 2 times x squared is 2x squared. 2 times minus 2x is a minus 4x. In order for this completing the square situation to work, we need a 1 coefficient here. All right, next step, I want to add in this some box number. So we're going to add in a box here. Y equals 2 open parentheses x squared minus 2x plus some box plus the 2 here. Now here's the kind of tricky part on this outside. Inside we added 2 times the box. Outside we need to subtract 2 times the box. Again, it's just keeping this right side equal. What goes in the box? Half of b squared. Half of minus 2 is minus 1. Squared is 1. All right, so now we will write this as 1 quantity squared. Square root of the first one first. It's always just going to be x. And then half of the b number. Half of the b number will also be the square root of that. This operator, this first operator, will always be what's in between. 2 minus 2 is 0. I don't have to put a plus 0 out here, but I'm going to. It'll help for writing my vertex. So a in this case is 2. My coefficient out there. That tells me that we're going to be opening up if we were graphing it. Thus, our vertex is a min this time. And our vertex would be located at HK. And that is the opposite of this inside number, inside inverse, and exactly that outside number. All right, and so the vertex, the y value of the vertex tells you about the range. If this parabola is opening up, then that would be the bottom, this 0 would be the bottom y value. So my domain in this case, as I said before, will be all reals. In my range will be y values greater than 0 because the parabola is opening up. That would be the bottom y value. Y greater than or equal to 0. Said using interval notation, we would say square bracket 0 to positive infinity in a parentheses because we don't get there. Either of these two are acceptable ways to express the range. All right. 41, we want to solve the quadratic equation 5x squared plus 6x plus 2 equals 0. 41, 5x squared plus 6x plus 2 is 0. Plus 6x plus 2 equals 0. All right, so I'm going to do it using the quadratic formula. The first step is to set equation equal to 0. That's done. Step 2, identify A, B, and C. All right, in this case, A is 5, B is 6, and C is 2. All right. Step 3, find the discriminant, the underneath part. If you find the discriminant first, you will find the quadratic formula is a lot easier to use, and the discriminant tells you some things. So remember, the quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. Well, this part underneath, the b squared minus 4ac, that is the discriminant, b squared minus 4ac. Find that first. So in our case, we have 6 squared minus 4 times 5 and 2. So that's 36 minus 20 and 2 is 40. That is negative 4. The discriminant, I'm just going to call it D. That's not a standard kind of deal, but if it's positive, if discriminant is greater than 0, there's going to be 2 real solutions. If the discriminant is exactly 0, there will be 1 real solution. And if the discriminant is negative, there will be no reals. It'll be 2 I solutions. And keep in mind that the real solutions will manifest themselves as x-intercepts. So if we looked at the parabola here, it would have 2 x-intercepts. The parabola here would have x-intercept on the x-axis, and the parabola here would have no x-intercepts. All right, so we know that the discriminant is negative 4. That means it's going to be no reals. It's going to be some I situations. So here I go, using the quadratic formula. Negative b is negative 6. Plus and minus square root of. We've already found this stuff under here. It's the value of finding the discriminant first. It's negative 4. 2a, and that's 2 times 5. All right. If the discriminant's a negative, start by making that negative a positive and put an I on the outside. So negative 6 plus or minus I squared root of 4 over 2 times 5 is 10. Well, the square root of 4 is 2, so we have negative 6 plus or minus 2i over 10. This is a perfectly legitimate way to write this, but let's do some reducing here. 2 goes into both of these, so that would be negative 3/5. 2 into both of these, plus or minus 1i over 5, which I would just write I over 5. 2 different numbers. It's 41. Lastly, I'll do number 50. It says, find the general form of the equation of the quadratic function. And by general form, we mean the ax squared plus bx plus c form. So they're giving us 1 point that's 3. They're giving us the vertex at 3, 2, and another point at 10, 1. Number 50. Vertex, that's HK, is 3, 2, 3, 2, and another point is 10, 1. All right, so let's use our vertex form. Y equals A, open parentheses, x minus h quantity squared plus k. I'm going to substitute 3 for h and 2 for k. So y equals a, open parentheses, x minus 3, quantity squared, plus 2. Now I just need to find a. Well, I will substitute in place of y and x our particular y and x value here, 10 and 1. 1 in place of y, 10 in place of x. So 10 minus 3 is 7. 7 squared is 49. We have 49a plus 2. Y is equal to 49a plus 2. Subtracting 2 on both sides and then dividing by 49 would be a is negative 1 over 49, I believe. We could substitute that right on back in here. Right there. Okay. And now we want to get into the general form. So we have right here, y equals negative 1/49th x minus 3 quantity squared plus 2. All right. We want to square this. We were trying to get into ax squared plus bx plus c form. We want to square this one. Well, keep in mind what we've been doing with that box number, and you can quickly do this. It's going to be the first one squared. It's going to be the last one squared. And the middle number is twice this thing, minus 6x. Notice if you take half of minus 6 is 3 and 3 squared is 9. We've just undone the box business. Plus 2. Could distribute the negative 1 over 49. I'm going to leave this to you, but I'm sure that you can distribute and then combine like terms because we're trying to get into ax squared plus bx. Trying to get into this. Ax squared plus bx plus c. The book is calling general. I will call either general or standard. Most books would call it that. All right, that concludes this video.